in the weeks 11, this linear integrator and dropout voltage regulator, which is one of the linear regulator. Regarding that, the theoretically how it works, and again switching regulator, and some few questions also related to that. We can do it. So you can see here, actually, I have taken these snapshots from the lecture only, whatever professor have already explained. Let me go for full screen. Okay. So you can see here, uh, in the linear regulator, like we are taking one operational amplifier, whatever it is covered in your previous lectures, this operational amplifier, and you are providing the input V in to this through this band gap reference filter. Like here, you can say that reference voltage will be applied, and you are getting the output here. So this output is nothing but connected to one kind of transistor, we can say that, which is nothing but voltage controlled current source. Means it can control this means like by using voltage only, but that will produce the current. So that's why it voltage controlled a current source. I don't think that you have studied about this voltage current control current source. So if we see in the next slide, this voltage control means like current source can be replaced by using some transistor. This is actually one kind of transistor. This has three terminals, and we can see that like here you are giving the input as the V input, and this output of this amplifier is connected here. Then from this terminal you are getting output. If you a little bit know detail about that, it has the three terminals, which is known as source, gate, drain. This is the source, this is gate, and this is drain. How does it work? Like whenever you see that source to drain, the voltage, this voltage is greater than equal to some threshold voltage, then we can say that this transistor can be acting as like current source. This is like, you can see that if you are looking at this source to drain, you are looking at the voltage. Like by using this voltage change, you can see this output will be, means like you can see that it will be producing some current. That means this relationship says about that this transistor provides you the voltage input you are giving, then you are producing current. That's why it is kind of working like a voltage controlled current source. Okay. But the thing is that, like, it is only acting as voltage control current source only at the condition that whenever this source to drain, this is one terminal source, this is another terminal drain, source to drain terminal voltage is greater than some threshold voltage whenever we are applying. If it is not, then what will happen? That means if it is the less than that condition, that time this transistor will be behaving as a switch, which is nothing but switch. If we are saying switch will be on, means if it is connected, then we can say that that can be producing some resistance value, very low resistance value. Also, directly whatever we are applying, that will come to the output. So that is only in the case of this whenever source to drain voltage will be less than this. Actually, this is just hints I have given, but the detail, I think, if you have taken EEC, EEC subject, actually this transistor is taught. Like if you have taken, it's good. If you have not taken, then next term you may take this course. But just for the time being, you should understand that here we are using some controlling source, like which is nothing but getting the input, and based upon this operation of this, we are getting the output here. So that means we can say that regulated output is nothing but this regulated output means it whatever the change it is happening in the circuit, but still the output remains constant based upon the your this registers value, and you're controlling like transistor, and based upon your whatever reference voltage you have applied. So this is all about like how it works. So if we come to the like low dropout voltage regulator, why the name is low dropout voltage regulator? Normally, you can see that input to output, whenever you see some dropout voltage will be there. It may be in the some millivolt, like 200 to 300 millivolt. So V input minus this dropout voltage will provide you the V out. So that's why the name is like low dropout. Why the name is low? Because if it is in the millivolt, 200, 300 millivolt or less than that, then we can say that no dropout. If this dropout voltage increases, then the performance of the regulator will be not good. If this dropout voltage will be as less as possible, then only you can say that this LDO, low dropout regulator, will be better performing. And we can see that this circuit diagram and the previous circuit diagram is almost same. Only the thing is that here we are just going to see that how the dropout is happening. Okay. So basically, whenever you are dealing with these regulators and all, we should know that what are the our industry perspective, which design will give you. Design means what? This resistance values, which resistance value you have to consider, and at which condition you are using, either it is in the current source for condition or switch form, that what according to the requirement we can do the designing. So for this designing we need some like a specification sheet. We have to follow that specification sheet will say that these are the features you should look into that whenever you are designing. For example, like input voltage range. If we are looking at the V in may be ranging from 1.4 volt to 5.5 volt. Similarly, you have to see that if it is operating in stable form, then that time what will be the output capacitor. That capacitor will be connected at the output side. So what will be the capacitor value? So similarly, all other these features will be looking into that whenever we are designing. Basically, another important parameter is low IQ. That is whatever quiescent current value. That tells about your stability of the or stable point of the regulator. That if this stable point is 34 microampere, then based upon the specification you have to change the resistance value, then you have to design it. Similarly, what is the fixed output voltage? If you need, like I have the input voltage is 1.4 volt to 5.5 volt, but I need 3.3 volt of output, constant volt output, then these things, if it is known, then only we can design the regulator. Okay. So these all are features, if you see whenever we are going for the designing the regulator. So coming to that, like we can see that like in the embedded system, whenever we are using the um, a chip. So I see whatever we are using, this is the pin diagram. So we are giving this capacitor. Whenever I was talking about this C out and C in, I was talking about that. Like you are providing some input signal, then you are getting this output at here by enabling this input. And you can see that like your dropout voltage, how it works with respect to the output current. So you have
And
like, yeah, hello, yeah, tell me.
anything from chart we have to remember? Any value, anything, or
No, it's not required. If you understand this, then I'm coming to the next, like how you are going to solve some kind of comparison, and some questions I will just do it. Okay.
okay, 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 okay,
Just you should understand it.
okay.
What is this? This is
Okay.
not required to remember anything.
Okay.
Okay.
Okay, ma'am.
Okay. So here you can see that, like, if you have constant of 3.3 volt you need, then that time what should be um, means output current based upon the input voltage whatever you have applied. So in this way you can design, like, for example, I need 3.3 volt, then but I have a means expected output is 180 milliampere, then what should be the VDD I have to provide. So accordingly that can be decided. So this is experimentally that has plotted based upon the values given in this sheet. Okay. So this is some kind of pin configuration for the like LDO or whatever the number it is given, like a TLV 743P. So for that, this is the like pin diagram, and the specifications are given, enabling when you are enable pin is working, then how you have to give the enabling output, and you have to drive that enabling on pin, then only you will be getting the output. Those things details are given here, pin functions, how it's function. So basically if you see this table says about that, whenever you are going to design any regulator you need to look into the input voltage range. That input voltage range will be given to you, like minimum 3 volt or maximum 4.2 volt. Then between these only you have to design. Typically output voltage, expected output voltage will be, if you are providing this range of the input voltage, what will be the expected output voltage. And similarly you need to look into that, what is the line regulation. Line regulation is nothing but talking about that output over the input, or whatever the regulation value is it, how much you have to see that based upon the requirement, and you have to take the input voltage and you have to change the resistance value, then you can get the output voltage. So similarly load regulation definitely depends upon the output only, because load is connected at the output. So that load regulation specification should be how much. So these are the specifications will be given to you. Based upon that you can design the regulator. So coming to that, like if we talk about like dropout voltage, this is a little bit important. You can focus on this slide. So dropout voltage, if it is given to you that 200 millivolt is the dropout voltage, like linear LDO voltage is 200 millivolt. So if you have the lithium battery, and that lithium battery has the input voltage of 2.7 volt to 4.2 volt, the range is of the lithium battery, and you are expected, you should get it like 1.8 volt. This is the required output voltage. So in which case you can get this 1.8 volt. How is it possible? So that means, like, you should design your dropout voltage, so that you will be getting V input minus dropout voltage should be greater than V out. Okay, then only you can see that, like, you can achieve this. Uh, 2.7 volt if I'm taking the minimum input voltage, and dropout voltage is 200 millivolt, it is given to you. That is nothing but zero point 0.2 volt, which is giving you 2.5 volt. This 2.5 volt, definitely it is greater than 1.8 volt. So that means if it is greater than 1.8 volt, means definitely we can able to get the 1.8 volt from this from this regulator. Are you getting this point? This is the design
Yes,
problem.
ma'am. Yes, ma'am. But this time, this is not act as a switch.
No,
Is it?
this is not acting as a switch.
Yeah, yeah, yeah.
This is this is acting as a current source.
Yes, ma'am.
Voltage control current source.
Yes,
Okay.
yes. Yes, ma'am.
So whenever you are opting for the switch, that time, for example, your required output is 3.3 volt with the same input voltage. Then if you are substituting this dropout voltage, then you are getting three. V input is like 2.7, and this if you substitute 0.2 volt, then you are getting 3.3 volt you're required. and this input voltage should be greater than equal, if input voltage is greater than equals to 3.5 volt, then only will be getting the 3.3 volt. If it is not, if you are getting three less than 3.3 volt, then that time it is acting as a switch. Are you following me?
Yes, ma'am. Yes, ma'am.
Okay. So this how this is coming. This is coming from here only. Whenever I have explained about this one, that means first condition satisfies whenever that is current source. Whenever second condition satisfies, that time it works as switch.
Yes, ma'am.
Got it?
Yes, yes.
Okay, so this is just in that specification sheet. This was the LDO given, like whatever I have explained, the same thing. The it is just vertically shown. That was horizontally I had shown. So band gap filter is there, and you have the operational amplifier. Then here you're controlling means like circuit is there. It used to control your output, that transistor whatever I had shown, a source, drain, and gate that is connected here. So based upon this, your it will be acting as switch, or it is acting as current source. That can be understood from here. Clear. So here it is given taken as a constant, like this resistance values. If you are varying, then variation of this like this resistance, if you replace with the potentiometer, then that based on changing this potentiometer, you also can control your output voltage based upon the input voltage. Okay.
Yes, ma'am.
So if you see here, the same thing again, it has talked like whenever you are talking about the voltage control voltage source, this is the reference voltage is control uh, based upon the reference value, and you are getting the output, and definitely some dropout voltage will be there. That drop V in and dropout voltage minus dropout voltage will provide you the output voltage. Okay, and this is required whenever we are designing. We have seen in the previous problem also. Okay, so if you go for the looking at that, what will be my gain of this operational amplifier? You know that this is non-inverting amplifier, so it will be like what should be the your R out, like the output resistance value. This R output, you know that R output will give you R naught over 1 plus A beta. You have already seen A beta whenever it is loop gain, then R out can be R naught over 1 plus A beta. So whenever A beta is so high or large value, that time R out will be so small. So based upon that, you can, whenever you are connecting your transistor here, then you are taking the output. Then that time, based upon this R out design, you can see that like how your output is controlled. Okay, so that's why this just given to link your previous lectures, whatever it was means taught to you, how that operational amplifier is related to this regulator. Okay, so coming to this body plot, you can see here, like whenever you can see here the loop gain is constant, after that it decrease at a certain point. You can see this loop gain means drops below the 0 dB also, right? So when you look into this the regulator, this works in this way only. So whenever we are dealing with this regulator also, we should look into that whenever we are connecting the output capacitor also, how it behaves, like when microfarad capacitor you are using, then the your output impedance falls down like this, and that time means your this amplifier gain increases in this way. So we can see that like effective what should be the effective impedance, so that our expected means output will be this one. So that according to that, we have to also design take the capacitor value and design the impedance, so that we can get the effective value. Okay, so if you see that like capacitor means if you are considering then sometimes means like if you uh, increase the frequency, so that time the capacitor will be behaving as inductance, and you can see that like inductor and capacitor effect together. Also you can see that inductor resistance and capacitor, this capacitor is similar with this capacitor and inductor resistance. Then again this is similar with this inductance, means effective value of this capacitor, if you see, that can be replaced with the inductor resistance and capacitor. So normally it used to behave like this is this kind of like you can see that here it dominates this um, means like inductor resistance and capacitive effect. And here it affects, it dominates, and it depends upon the capacitor value, whatever the capacitor value you have taken. So based upon that you are finding out the resonance frequency. That frequency already you know that 1 over 2 pi root over of LC. Okay, so similarly based upon the capacitor values we may get the different resonance frequencies. Yeah, and we can design accordingly. Okay, so coming to the like this regulator, whenever we are dealing with that, for example, this is one of the example that how can we know that it is efficient or not. Finding out the efficiency, we can know that is it how much efficiency this regulator is, that depends upon your what is you're getting the output power based upon the input power. So for example, input voltage 2.7 to 4.2 volt, whatever in the previous case we have taken, if it is that kind of battery we are using, and the expected output is 1.8 volt, and the load current is given 100 milliamperes. So that time how can we find the efficiency? Output power will be like your output voltage multiplied with your current value, load current, that will be giving you 180 millivolt. Similarly if you see for the input power, so here effective input voltage is taken 3.6 volt. 3.6 into 100 milliampere will give you 3.6, 360 milliwatt. So efficiency says about output over input, output power over input power will give you 50% of efficiency. So if this 50% of efficiency you are getting whenever you are connecting you are expecting 1.8 volt, this regulator provides 1.8 volt, and your load current is 100 milliampere, that time you are getting 50%. So if we consider the other case, like this is the case current source, whenever it acts as current source of 100 milliampere, and the input the expected output was 1.8. If the expected output is 3.3 volt, okay, so that time we can see that the output power will be 30 milliwatt, because our output expected output is 3.3 volt, input power is 360 milliwatt. In this case we are getting 90% of efficiency. So we can see both the cases how the efficiency matters based upon the your output whenever we are stabilizing the output based upon the input. Okay.
Yes, ma'am.
Okay. So coming to the switching regulator, in the switching regulator, the difference is that we can see that the switching happens based upon your duty cycle. So basically, your efficiency is determined by using V out by V in before you are doing. Now V out by V in and multiplied with the duty cycle, and that will provide you the now, if we compare about a linear and linear regulator and switching regulator, linear regulator has less efficiency because we have seen here 50% is nothing but a linear regulator. If we are going for the switching, means when this acts as a switch, that time the efficiency increase to the 90%. So efficiency increases, and the cost of the linear regulator is less, and the cost of the switching regulator is more because we are using inductors here, and inductors is heavy to use, many windings and all are there. there. That's why it is costly. And in the case of linear regulator, it is minimal external use, but it is better rather than the switching regulator. So whatever the means like components we are using here, that is means like easy to use, but here inductors and all are there. That's why it is little bit complex. Similarly, in the case of like applications, linear regulators in the real estate we can easily use as compared to, basically you can see that like because of these inductors are used in the switching regulator, it costs more for the switching regulator. So coming to this question, let's do some questions whatever I just talk about the background. So the question is given for an output impedance. If a 5 micro farad capacitor produces 20 kilohertz frequency, the value of effective series inductance is how much Henry? It should be in the millihenry. Can you just tell me, because I have given the hints. You can use this frequency, this formula that resonance frequency is F equals to 1 over 2 pi root over of LC.
Yes, ma'am. We have to find L from here, and
Mm-hmm.
F is given, and C value is given.
Mm-hmm.
Uh, uh, then we have to calculate L from here.
Okay. Can you calculate and tell me how much you are getting?
Okay, ma'am. Please give me some time. I'm doing.
Mhm.
Ma'am, is it 0.063 millihenry?
So have you converted all the values? Have you applied this for this way? How I have written? Can you see the screen?
Yes, ma'am. Yes, ma'am. I
So
have
have you
done
converted?
F at to convert it to hertz and C 5 into 10 to the power minus 6 farad.
Yes.
Yeah, yeah.
So you will be getting the answer is 628.32 into sorry,
Yes,
not
yes.
6 to no, this is
6
not.
3. Ma'am, that will be whole square. 2 pi into 20 into 10 to the power 3 whole square. It
Yeah,
will
it should be whole square. Yeah. So it will be
You can eliminate 10 to the power 6 and 10 to the power minus 6.
yes, yes, yes.
Then it will be easy to calculate.
So are you getting 1.26 into 10 to the power minus 5?
1 point.
How much you are getting? Can you see? Tell me.
I think I am wrong during
Yeah,
calculation.
you have to multiply 2 multiplied with pi multiplied with 20. So you'll be getting 125.66. You have to take the square of that, right? So you'll be getting 15.79, 15,791. Then you have to again multiply with 5. Then you have to take the inverse of that. That will give you 1.267 into 10 to the power minus 5.
That will be,
So
ma'am,
then
in Henry.
Henry, you
Yes,
want
ma'am.
to do it to the minus, like millihenry. Millihenry means minus 3 if you are taking out. That will be how much? 0.1 0.012 into 10 to the power minus 2 millihenry. This minus 2 will not be there. Already you have taken here. So here 10 will be there. 0.012 millihenry. Are you getting this answer?
Okay, no, no, ma'am. I am getting 0.063. Maybe in calculation, wrong in calculation.
No, have you taken 1 over the answer? Because
Ye-
1 over 2 pi, then multiplied with 20 square, multiplied with 5. 10 to the 6, 10 to the minus 6 will be cancelled out, right?
yes,
So
ma'am.
this you have to take. So whenever you will be doing this, then inverse you have to take because 1 over this is there. Then
Yes,
you
ma'am.
will be getting this answer.
Actually,
Then you
I
have
have
to,
multiplied 1000 there above.
okay. Okay, then you have taken again square. So that will be again lengthy because 10 to the
Yes,
power
yes,
3
yes, ma'am.
bar
Yes, ma'am.
2 is 10 to the 6, 10 to the minus 6 will be cancelled out.
Yes, ma'am. Yes, ma'am.
It is easy to take in this way.
Yes, ma'am. Yes, ma'am. Okay, 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 ma'am.
So just a second question, let me show you. So this is the second question. If I show this question, so for the given waveform, the efficiency of the switching regulator is what? So the efficiency of the switching regulator I had shown you here. The V out over V in duty cycle, if you are multiplying, then only you are getting the efficiency, right? This is the formula, right? So if this formula, how can you substitute here? Are you following me?
Yes, ma'am, I'm following you.
So how can you substitute here?
The ma'am, it is I can't see the
Yeah, this is the question. Duty cycle is what?
this is wow on portion that
On
is
over off.
yes
2 over 5 is duty cycle,
yes
right? Then your input is given 3, output is given 1.
one yes ma'am
So if you substitute here V out over duty cycle multiplied with V in, then you will be getting.
one
So
by
this is the formula. You can see here, like whenever you do it, this is actually we know efficiency always we talk about in the power form. But
yes
if you
ma'am.
take the constant current, then your V out over V in multiplied with duty cycle. And duty cycle is 2 over 5, right?
Yes
Is
ma'am.
zero point 0.4. And you are getting input voltage is 3 volt, output voltage is 1 volt. Then if you substitute here 1 over 3 multiplied 0 0.4, then you are getting the efficiency of
Yes, ma'am. I
80%.
am telling that is on portion. Duty cycle is that is 5 2 by 5. Yes,
2 by 5 on
yes,
over off duty
off. Yes,
cycle.
yes, ma'am.
2 over 5, right?
Yes, ma'am. On over total cycle. On over total cycle. That is 5 from 1 to 5. 0 to 5, I think.
On is 2, right? This
Yes,
is 2.
yes.
Okay.
Then
And
total 0
this
to
is
5. Yes,
on
yes.
plus off will be total 1 to
Total.
5. Yes,
Yes,
yes, yes.
yes,
That
ma'am.
is correct. That is correct only. T
Yes,
on
ma'am.
over T on plus T off.
Yes, ma'am.
So 2 over 5.
Yes, ma'am.
So similar kind of questions you may get related to the switching regulator and all.
Okay, ma'am. Okay.
Okay. So
Okay, ma'am.
next question is that this one. Just don't look at the solution. You just see. This is the mm, a regulator we have seen that amplifier works, and this is not that different from your operational amplifier, whatever you have studied in other lectures. So here you can see this has the reference voltage of zero point 0.5 volt, and you have R1 and R2 value. The question is that like what will be the V out if you have given the reference voltage of noise at 2 kilohertz. So that time this is easy for you, right? To calculate as a normal op-amp it used to be.
Yes, ma'am. As it is non-inverting,
Yes, that will be
then
1
it will
plus
one
this
plus. Yes.
30 over 10.
Yes, ma'am. That will be 1 plus uh, RF by RIN into.
Yes, and RF is 30 kilo ohm and RN is 10 kilo ohm.
Yes, ma'am. Then gain will be that.
That is only gain, na? V means like you are
Ma'am, that
getting V out by V in is that much. So if you get the gain, then what will be the means output you will be getting? That is nothing but output is nothing but input multiplied with the gain.
gain. Yes,
So
ma'am.
already input is given to you in the question that reference voltage if you are taking a 20 millivolt, then what will be the output? And similarly, in the second question, it is given if your reference voltage is 10 voltage, what is the VO? People used to be confused with the question, but it is very simple.
Yes, ma'am. Input noise will be continue in the output also.
Yes, 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 yes.
Yes, ma'am.
Okay.
Okay.
This is just related to the regulator, some few questions. So I think you can just do more questions which is given in the practice thing. Okay.
Okay, ma'am. Okay.
So we can wind up because only one student. I don't know is why the people are not joining and all. This is only first time actually I took this session. I was taking other courses. So this is
Mostly,
the
ma'am,
last.
only I do the all classes from starting to end.
Okay, so Mandal.
Ma'am,
Ankit sir know that.
Okay,
Yes,
okay. Ankit sir is taking. So you people are coming for the lab, right?
yes, ma'am. We are coming.
Uh-huh. Okay, we will meet. Okay, on which day you have the labs?
3, 4, ma'am.
Okay, okay. You are coming for the analog lab.
Part 1. Yes, ma'am. Analog lab.
ma'am,
Hmm. I think another person joined late, I think. Sananda Patel. Yeah,
yes,
tell me.
ma'am. Ma'am, I have some questions that I am not able to solve. How to solve it? I am not getting. Can you please uh,
Which questions? Tell me.
that percentage error questions?
Percentage error question. How can I know? Because I am not taking your regular classes, right?
Yeah,
So
yeah,
if
yeah,
you tell about that percentage error, then I cannot understand. Tell me
yeah.
whole question, then only.
Ma'am, I will share my screen. Can you please solve that?
Yeah, yeah. You just share your screen. What is the
Okay.
issue? Why not? Why are you not able to solve this? Is this the graded assignment question?
Actually, it is a graded assignment also, and
But graded assignment, if it is, then I should not solve it.
like
But
that is
still, you
week
share.
10,
It.
deadline
But
passed.
still, okay. Share your screen.
Let me open the dashboard.
Are you sharing your screen?
Yes, ma'am. Internet is also this question, ma'am, and one PYQ also is there.
This is the graded assignment question only. The variance in output voltage is that's percentage when the 0.3% R1 resistance and 0.45% R2 resistance is faulty. R1 in 2 times R2. Huh? Oh, what is the issue? Tell me. I will not solve directly. You just answer me wherever you are struggling, then I will guide you.
Like here, what to do? Like faulty means it is extra. The
Okay, you are
resistance.
not getting the question. You are not
Yeah.
understanding the question.
Also,
So,
not understanding the question and concept. Also, I am not clear.
you have not attended corresponding lectures.
Actually, ma'am, I
So
am
here,
in a full-time intern, so I am not getting time some days.
full time,
Intern,
where?
ITM.
You are like dedicated course you are taking, right?
Yes, ma'am.
Then you should do it. Okay, no problem. I'll just help you. So, first of all, you should understand that what is this question, right? So,
Yes, ma'am.
it has given the variance in output voltage is dash percentage when the 0.3% R1 resistance, 0.45% R2 resistance is faulty. Faulty means what? The resistance, whatever the value should be given. Like you should get that. Like for example, 10 ohm resistance if I'm using. Okay,
Yes,
so 10 ohm resistance should produce whatever the drop. across that 10 ohm, it is not producing. That means like some faulty is there in the resistance value. Means whenever we are measuring, that 10 ohm will not show the 10 ohm. It will show something 9 or 8 ohm like this. Those kind of things are known as a faulty. Okay. So if you have the faulty resistance, so let me um, take my screen share and explain to you. Sorry, my tab is connected. Yeah, the question if I take here, let me write the question here. This is R1, this is R2. Then it is given R1 is equals to 2 times of R2, and it is given like your R1 has the fault of 0.3%, R2 has fault of 0.45%. Is it? Am I right? This is given in the question, right?
Yes, ma'am.
Okay. So then it has asked you to the variance in output voltage is dash percent. Means your output. First of all, just understand the question. I don't want to solve the question first. I wanted to explain it. This R1 and R2, whatever the value is there, that has the fault of means like R1 example means like X ohm. Okay, X ohm has 0.3% of fault. That means if you see X multiplied with 0.3% is your whatever the resultant R1 you are getting, that R1 is not equals to actual R1 value. Are you understanding my point?
Ma'am, R1 value will be R1 plus minus 3%,
Yes,
0.3%.
plus minus 0.3%.
Yes, ma'am.
Okay. So similarly, R2 is also is fault of 0.5% plus or minus 0.5%. That means you may not get the whatever R2 value is given, that may not be equals to the actual value it is given. Like I was saying 10 over 10. So that time it is saying that like this here it is given R1 is equals to 2 R2. It is saying that if your R1 and R2 has this fault, what will be the variation in the V out? Are you understanding?
Yes, ma'am.
Are you understanding?
Del
Okay.
V out by V out. We have to find del V out by V out.
That question again, let me see. The question has asked you to the variance in output voltage is dash percentage. Yeah, means whatever the V out you got it in case of R1 fault minus V out of R2 fault, that will give you del V whatever you are saying.
Yes, ma'am.
Okay, so now you tell me, if you take this fault or fault value, then without taking fault value also, what will be the V out value? Can you tell me? V out will be what? How much? How can I write the expression? This is the total V in. Total V in is divided into across the R1 and R2, right? V out is the voltage across the R2. So can I write voltage divider rule I can apply, right?
R2
R2 V
into V
in over
by
R1
sum of
plus
R1.
R2. This will be my V out, is it?
Yes, ma'am.
So then next you already have the information. I'm just a little bit scrolling down. You got there. Just again I'm repeating here. R1 equals to 2R2. Then your V out is equals to V in R2 over R1 plus R2. So can I write here V in R2 over 2R2 plus R2? Can I write? So
Yes,
can
ma'am.
I write this is V in equals to R2 over 3R2? Can I write?
Yes, ma'am.
Then can I write V in is equals to 1 over 3? This is nothing but V out.
Yes,
So
ma'am. Till here I am
final
getting.
till here you're getting.
Yeah. After that I am not able to proceed.
After that, you are not able to process. Okay. The tolerance value is given you. Tolerance is nothing but this variation, whatever it is saying, plus or minus 0.3% is nothing but we can say that plus or minus 0.003. Similarly, plus or minus uh, for 0.45%, I think it was the, I forgot.
Yes, ma'am. It is.
Huh. So that means it is nothing but plus or minus 0.0045. We can say this is the tolerance value, right?
Yes, ma'am.
So now new resistance R1 dash can be written as your what will be the value? 2R2 you are saying R1 equals to 2R2. Can I take it is R1 is equals to R, then R2 is equals to means sorry 2R. R2 equals to R means so with same value if I'm taking it is easy to calculate. I'm just assuming R2 is equals to R, so R1 will be 2R, right?
Yes, ma'am.
Can I take? So can I write this is R1 equals to 2R2, so I'm writing 2R. Okay, then you are getting the plus or minus of how much? 0.3%. So that means I can write 1 plus or minus also I can take 0.003. Can I write?
Yes, ma'am.
How is this coming? Just a little bit I'm explaining because you can confuse here. I'm just writing R2 dash also, then I'll explain R 1 plus 0.0045. How is it coming? See, R1 has 0.3% of variation. Means R1 into 0.3%. Okay, so that is nothing but you are getting this much of variation. But previously it was there R1. You are getting the variation of this much R1 multiplied 0.3%. Okay, so this is nothing but R1 plus or minus R1 multiplied 0.003. Are you getting?
Yes,
Okay,
ma'am.
so this is nothing but R1. If I take common 1 plus or minus 0.003. Is it clear to you? So if you see this only I have written here, means like this is in the form of R I have taken. This R1 is equals to 2R2 and R2 is equals to R. That's why I have written this. Is it clear?
Yes, ma'am.
Similarly, I can write R2 also.
Yes, ma'am.
So now this is clear how it has come. Now you have to
Yes.
substitute in your V out. Now new V out dash, I can write V in R2 dash over R1 dash plus R2 dash. Can I write?
Yes, ma'am.
Then here, how much you will get? V in R2 dash is how much? here 1.0045 R,
Yes, ma'am.
1.0045 R over, I can write R1 dash plus R2 dash. That is nothing but R1 dash is 2 times of R. That means 2 times of 1.003 R plus 1.0045 R. Is it clear?
Yes, ma'am.
So from here, then you tell me how can I write V in? This RR will be cancelled out. You can take common from the denominator, you can cancel out. Then you are finally getting here 1.0045 over 2 multiplied with 1.003 plus 1.0045. You tell me now finally how much you are getting. Tell me how much you are getting. Is V out dash. I can write V in multiplied. What is the factor you are getting here? Shall I use the calculation or you are using?
Is it 0.333?
1.003 plus 1.0045. Okay, that inverse this multiplied with 0.45. You are getting this value is 0.33, right? Is it? Are you getting this one?
Yes, ma'am. It is.
Okay. So this is your 0.33 you got
Alright.
it. Pardon?
Yes. So sorry, sorry to actually someone came to room.
Okay, no problem. So now you got this V out dash is equals to V in 0.33. Previously you got here V out is equals to V in multiplied 1 by 3. This 1 by 3 also I think it is giving 0.333. So that's why it is better to take here some 4 5 decimals. So it is giving 33367 you can take. Are you getting? Otherwise you will get
Yes,
answer
ma'am.
is
It
0
is. Yeah.
6 7. So this is value. Then this is 1 over 3 means that will give also 0.33. This is nothing but V in 0.333 like this. Right? So now you have to find the variance. Variance is nothing but you will be getting variance means what? Whatever you got it and whatever previously it was there, the difference you have to take. That is nothing but 0.33367. Your friend already answered about that. 0.33333 divided by with respect to what original value. What is your original value? 1 by 1 over 3. 0.3333. Right? Got it?
Yes, ma'am.
Yes, ma'am.
This is nothing but known as your friend was saying del V, and this is your original V out value. But I don't want to write in this way because that will be confusion. You got this value and this value. This is your due to tolerance, and that was your original value. And normally variance used to be what? Your current value minus the original value divided by original value. That is any case. Variance
Yes.
is this formula, right? So this way is giving how much? You calculate and tell me how much you are getting.
0.00109651220072.
Percentage you have to convert, right?
Okay, okay, ma'am. Sorry.
It will be ma'am 0.1.
Yes, ma'am. 0.1.
1.
Yes, ma'am. Now it is correct. I did some mistakes. Like I followed the same, but in the last you told variance equals to this formula, right? So I didn't got it previously, but now it is clear.
Is it clear?
Yeah, yeah. Till V out equals to V in into 1 by 3. Till the here I calculated. After that I
But
was
you were not getting these things. The majorly, if you understand first, try to understand the question. Then only you can. Okay.
yes, ma'am.
So then directly. So that's why again here I have again expanded so that the confusion should not be there.
Yes, ma'am.
Right.
ChatGPT also doing the same. So uh,
But chat GPT, if you're doing, then you should understand also, right?
yes, ma'am. Now I am getting properly.
Uh,
After that.
no, you may take the help of, but sometimes chat GPT won't give the correct answer also, right?
Yeah, yes, ma'am. That's
Some
why I
mistake,
wanted.
some mistake will be there, then you will not be able to. Okay,
Yes,
any
ma'am.
other doubts are there, or can I then stop the class?
No, ma'am. I'll try and next session I'll ask. Yes.
Okay.
Ma'am,
Soma,
you
is
are,
it fine for you also?
Yes, ma'am. It is fine.
Okay.
ma'am,
Okay.
you are in ICS now.
I'm taking ESTC, and this actually live session I have not taken for this AES. Just I was setting the question paper and all.
Okay, ma'am.
Uh,
Actually, sometimes I
evaluation.
used to do ICSR and study there.
Uh, do you know who am I?
No, ma'am. Ankita,
No, no, I am Saswati Paramita. Like Vasundhara is taking and Ankit sir is taking, right? Your course. So we'll
okay.
be meeting in during lab.
Yes, ma'am.
Okay, 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 fine.
Thank you,
Okay,
ma'am.
ma'am. Thank you.
Bye, bye.
Bye, ma'am.